Welcome, everyone, to our session on bias and data loss in transcription generation. Your speaker today is Jeffrey Boucher. He's the head of data engineering at the UCSF Library. He provides consulting sessions and workshops for researchers and staff with a focus on Python, SQL, data access and transformation, natural language processing, and machine learning. Turn it over to Jeffrey.
Thank you for coming, everyone. I guess, let me see, before we get started, I just wouldn't mind doing a quick check. And I'm going to ask everyone online, can you hear me and see my screen? This is the first question I ask in every workshop as well. So, just, type in that you can. Okay, great. Thank you. Always good to hear from the first person. That means, it's working at least. So thanks for coming. And, we got a small group today. I think we can, that can work to our advantage because I actually asked for questions not to wait till the end, but rather please feel free to ask questions during the presentation. I'm actually using my laptop on this because I want to demo some code and some other things, some web searches. If you have your laptop with you, you might have a chance to look at some resources as well, and feel free to ask questions. And I'm also doing, I wrote bias through data loss rather than and data loss. The original title was and. But actually, I wanted to talk about how, people like me who work at libraries or in research groups who are generally responsible for building data pipelines don't think of ourselves as people who make necessarily research decisions about data, but we often do end up creating influencing the data sets that we hand to researchers. So this talk is for people who work in that area, as well as researchers who work with, programmers and analysts who may be creating data sets for them. The specific topic of discussion here is transcript generation, because this came up in a few projects that we did at UCSF using some of the collections that we have at the library. And so I'll get into some of that, but I'd like to start with, let's see. So I know this is kind of a long slide. I'll read it for you. Advances in AI technology make it possible to provide speech to text, image to text, sentiment analysis, object recognition, and document classification on a large scale from digital collections. For instance, the tobacco industry documents at UCSF have about 1.7 million documents in them. These are lots of different media types: newspaper articles, letters, handwritten letters, industry videos, anti-smoking videos. There's a huge amount of data in here. And the effectiveness of these technologies and the accuracy can vary dramatically depending on the document collection or even the document type. Probably won't surprise you to know that cursive written jotted notes in the margins of a PDF file, cursive letters, they don't translate to the same level of accuracy as, say, a very well-typed document that was scanned. Those may translate very well. So here's the problem. What kind of bias do we introduce into a data set when we tell researchers, these are the topics that were discussed in this collection, when in fact, not all the documents are translating with the same level of accuracy? Okay. So I think that was a long explanation. So we were talking about this yesterday, and many of you have heard the story of the street lamp. This is apparently a story very popular in the 1920s. I was researching this. A Massachusetts Boston police officer finds a drunk looking for his keys under the lamp. Where did you lose your keys? At home? Why are you looking for the keys under the lamp? Because the light is so good here, right? And apparently the story goes way back and is popular in many, many different cultures and parts of the world. And, we know the answer is the light is better. So it turns out there's a 2023 version of this story, which is some researchers were interested in analyzing how perspectives on smoking changed over time. So they analyzed a huge trove of digitized handwritten letters, community meeting notes, newspaper articles, posters, medical records, and legal documents. But the perspectives that they identified said was what was being discussed mainly emphasized the perspectives in news articles, legal and medical documents, to the exclusion of, say, the letter writing campaign. Why? The light was better. So this is the topic that I'd like to try to discuss here. Okay. So this is an example of a document that's in the tobacco archives. And I'll give you a chance to look at the tobacco archives during this talk here. I have a little bit of trouble reading these myself. This is part of a letter writing campaign where people express irritation with some of the cigarette companies. Sometimes they express irritation about the health effects. Sometimes they express irritation that they didn't get their free carton of cigarettes through, and basically these are a tremendous number of documents that were turned over to UCSF by the tobacco companies as a result of litigation. They had to make it all public. They had to turn it over to the public. Research is in the public. So this one gets translated like this. All right. This is a massive improvement over a few years ago. It's really evolving quickly. I wasn't at it. I understand there was a talk just the previous session where Amazon was had some tools to do this. We'll use Google Auto ML today. But again, it's improving a lot, but nonetheless, there may be some very different perspectives expressed in handwritten letters that we're not going to collect very well. Now here's another one. These are all from the tobacco archives. This is another one about, I guess, some sort of innovation to prevent health problems resulting from smoking. I didn't keep all the metadata. My guess is it's a pretty old article. And this translates much better. So again, if we were to build a topic model out of the documents in this collection, we would almost certainly be building topics that are reflective of the data we're actually collecting. We're studying perspectives where the light is good, would be what's happening here. All right. So the UCSF Industry Documents Library has we have image, audio, and video media for a lot of things. As I mentioned, there is handwritten letters, there are advertisements, healthcare outreach posters, legal depositions, clinical notes, newspaper articles, community meeting notes, and I'm kind of curious about that myself because I don't think anyone's looked at all of them. This is one of the reasons I think people are so interested in text extraction, and the IDL team does provide very large scale document translations right now for image and PDFs, but I believe not for video. However, they don't contain certain artifacts that are available now with more modern tools that I think will be very useful, in particular confidence scores and how well was the how well was the translation done. All right, so here's some things to consider. These are just a few things that I thought of while I was looking at the collection. So the first is, will the transcripts generated from handwritten letters have the same accuracy and completeness as the printed legal documents or the industry press releases? Maybe not. One interesting study was to see how does the industry respond to public service announcements about smoking, right? There's a little time lag. That can be interesting. Another was, does the sentiment score, that is whether the positive or negative sentiments expressed, did that change when the courts required that anti-smoking ads be funded not by the tobacco companies themselves, but by, nonprofits? Did the sentiment scores change? That's another thing you might consider looking into. Suppose that you have a video file and it was of, a news show where someone's speaking in very clear, slowly, with the kind of accent that machine learning models are trained on to recognize speech. Will that be as accurate as a community meeting with lots of people speaking at the same time? Probably not. Probably not. Another thing is a lot of posters have images and watermarks. There is document recognition capabilities as well in these systems, but the people who are collecting this may not know about them. They might not be using them. They may not be so effective, especially with things like watermarks. And in fact, there's some things you'll never get if you don't look at a collection physically. You might actually, if you go and actually look at the letters, you may actually notice things about a document that could be used to classify it, like the thickness of the paper or how old the paper is. You know, you might know that the where the letter was written. Maybe there was hospital watermark on the stationery. So there's a lot you just aren't going to see. So if you can, it's good to even try to interact a little bit with the real physical documents. Go to the library and look at them. You don't have to look at all 1.7, but just get a sense of get a sense of what's in there. And then lastly, this last question here is kind of the important thing to keep in mind is what and whose perspectives will be included and what would be excluded if you rely on, because we really can't assume that all perspectives are equally represented in all document types. Like letter writing campaign, especially when you're dealing with historical documents where they're all being handwritten. Yeah, you really, if you're only losing, say, 5% of your information, but you can't assume that's evenly distributed in all the documents, that 5% may represent its own topic that you now don't see. All right. So here's a lot of things that I think you've probably heard people talking about during this conference. Topic modeling is one of them. Anyone here do any topic modeling? Have you seen like a GenSim topic model? Okay, well, this is an interesting machine learning algorithm. It's a type of unsupervised machine learning typically, where you can train a machine learning model, a topic model, to simply look at a huge amount of text or something similar. And you would ask it, what are the main topics that seem to emerge? And the way that these topics are typically identified is certain word clusters. Words happen in certain relationships with each other. It will report on them, maybe 5 or 6 of them. And you can look at those and see their distance, the distance of these various word clusters from each other. And you can tell that there may actually be distinct topics rather than just a general large text collection. That's one. Machine learning is another. This is something we may do at the library. We're kind of running a pilot on. Can we use our existing metadata for documents that we have looked at, along with transcripts? Can we train a machine learning model to extend our metadata into documents we haven't seen yet? Right? We may be able to do that. But again, we're probably not going to add good metadata for documents that don't have good transcripts. We couldn't if we don't have that data. So unfortunately, if we build that into search, we may be directing people toward one set of documents and not toward another. Sentiment analysis is one I just brought up. That's a type of kind of classification where machine learning models may try to determine if there's a positive sentiment or a negative sentiment expressed in a document. That's very commonly done. Again, the example I gave you of maybe, tobacco companies once funded their own anti-smoking advertisements, and they probably didn't contain as negative a sentiment as maybe some of the community ones did. So again, that would be something that you'd really want to know, and you would be feeding the data from this into it. You've probably seen word clouds. You may have seen that. Like, what were the big words associated with this collection from, 1900 through 2023? You might find that, there was a period of time where, doctors recommended smoking, and, maybe like athleticism was emphasized, and you can see big word clouds that will show you what was being discussed. But again, we're only knowing what's discussed in what we managed to extract. Automated summarization is another one. I think people may be starting to use OpenAI for that quite a bit. There are other technologies, where we have 1.7 million documents. We'd love to get a quicker description for them. but we're not going to be able to have somebody do that for all the documents in the collection. We might be able to use some AI to do it, but again, the concern is that you're actually compounding the problem of certain perspectives are already marginalized and underemphasized, and you may be compounding that. AI is just going to square it. You already had it, and now you've got it even more. And then chatbot training. You're training a chatbot to respond certain ways to certain questions, while maybe you just gave the industry overwhelming emphasis in how questions are going to be responded to about some topic, because their documents were all in a format that's easily translated. Like maybe you trained it on speech, right? And then some perspectives happen in community meetings, which are not as easy to translate. And you're training your chatbot to respond. Maybe this could really throw it off into a different direction. So I see these as all things that data scientists, research, and so forth are interested in doing, and they may not know the extent to which a tremendous amount of bias has already been injected into their data through the process of providing it to them. Okay. So this is a moment where I actually would really like you to have a chance to look at this. So, I know it's a presentation, but you could go to industrydocuments.ucsf.edu. Let me see if I can bring that up here. Oh, I have some suggestions too that we can look at, but I think you can see this. Maybe I could just quickly ask in the chat again. They can see it? Okay, great. So this is the industry documents page. And I don't know how many of you have seen it before. And I'd like to give you a little tour of it. You can search for lots of interesting things. I think one of the terms that the industry document library uses, eggplant, because apparently there's some chemicals that are common to tobacco and eggplants. And, so here we have our results. And you notice some of let's take a look at this one. So 1-page PDF. And it's on its side. There's a lot of kind of, I don't know what to call it, dots in it. Artifacts. And I don't know what this number means. And looks like it's from the International Herald Tribune front page on August 6th. No year, but I think we can get that from the metadata over here, 1993. And so, again, I think this would have really thrown off. In fact, this would have really thrown off a lot of document extraction even 5 years ago. It's going to get it now. It actually is much better. Though I think if we looked at this one, you'll see that it'll translate it, but it thinks this is a sentence, so it kind of flips it. It doesn't read in columns. Maybe it would if it had been upright, because I wouldn't be surprised if, again, as time goes on, I bet you these algorithms start to recognize that it's a newspaper column, the newspaper article that has columns to it. But that's one example of a document. What do cigarettes, tomatoes, green peppers, and eggplants have in common? Yes. Let me see if I can type in handwriting here. And we'll get a few things that are handwritten, I think. All right. Yeah, so this is a good one. I'm showing you some really, they're not all like this, but I've attached my revised presentation. I did make it shorter. That's one thing. So, if the document translation can get this, that's better than I'm going to do. Looking at it for sure. And I just want to show you a few other things about this. It's very important to me to show you a few other things. There are other industry documents in this site. And lastly, let's go back here. Oh, there are videos too. And we can demo today some videos. So if I click on videos, you see that there's like a lot of old commercials, including some anti-smoking commercials. I'm not sure this is going to work because we don't have audio. Is that the case? But you could click on it on your own if you want to check it out, because we can do a translation on this one, and you'll see it's pretty good, but it's not exact so far with the technology I'm using, the way I have configured it, because there's a lot of fine tuning of these things as well that is kind of collection dependent. Okay, and then lastly, I know I said I'd like you to take a moment to look at this. If you go to research tools and go to, where was it? API and data sets. I just want you to know that there are pre-built data sets. So you don't have to do all this yourself, but it's not going to have some of the things we have now. In particular, it's not going to have accuracy scores. And, you know, that's, I think, something that, you know, people who provide this sort of thing will start to add more and more often now that it's increasingly part of the services. So, all right, so that's about it. So here's what we could do. What time is it? It's 12:22. How would you feel about taking 5 minutes just to browse this site and just see if you find anything you find really interesting? If you find something you like, you could put it into the chat and we could try, because I'm going to run live code here. Yeah, so I could try getting it. We could see how it goes. Otherwise, I've got a bunch of suggestions. So while you look at that, I'll just I'll go back to my slides. Where are they? Yeah, that would be helpful. I'll put the URL into the chat. Yeah, that'd be good. Okay. Because everyone in the room's is on the chat as well, right? Oh no. Yeah, that's right. You wouldn't be. Oh well. Yeah, maybe it's better. It's not too hard to type. Maybe it is better just to type industry documents UCSF.edu. That would probably be the best way to go about this. And I really think you'll get more out of the second half of this presentation if you just have a little time to look at this. All right. Well, I really, really hope that stopping in 5 minutes feels way too soon to you and that you're really interested in these documents because they're here for researchers. And I consider, you know, everyone who uses them and are really interested in, you know, gaining some insight into how things work from them, you know, because we've heard, I'm not on the team that manages this, work with them a lot. And, you know, they've done lots of, you know, presentations at colleges, campuses, and people find it very eye-opening to see, you know, how language is used, you know, and convince people to respond to public announcements, to, you know, create uncertainty, things like that. So I want to try to play this, so maybe it won't work, but let's try. So this is a California anti-smoking commercial, and I'm going to play it. Let's see if I get anything out of it.
Well, gentlemen, the tobacco industry has a very serious multi-billion-dollar problem. We need more cigarette smokers, pure and simple. Every day, 2,000 Americans stop smoking, and another 1,100 also quit. Actually, technically, they die. That means that this business needs 3,000 fresh new volunteers every day. So, forget it. Cancer, heart disease, emphysema, strokes. Gentlemen, we're not in this business for our health.
Right. So there's let's try that. Interesting. Yeah, my mute. Oh, yeah, it was my speaker. That It helps to look up at everyone who's trying to tell you what's wrong rather than looking at your screen and pushing buttons. All right, so there was, this goes on further. There are actually a lot of ads that don't have any speaking and just have some text at the end that we're not going to get when I just extract the audio. It doesn't capture the evil laughter, so that's something. But let's go ahead. So I'd like to go through let's see here, bringing up that at a Jupyter notebook now. And I wanted to show you how this works for a couple of these. So we'll do one PDF and we'll do one video. Yeah. What is it you're looking to? I'll make it a little bigger even. How's this? Is this okay? Okay. Yeah, there was just, yes, I'll we just asking me to make this a little bigger since there's people in the conference room. So here we have 3 of these. We'll go ahead and extract the transcript from an MP4. And there's a lot of clutter in this. I'm actually not running I already ran this one, so we may as well. I didn't see any reason to rerun. It takes about a minute. It only takes about a minute because it's a short video. Really long videos that are 2 or 3 hours can take 15 or 20 minutes to extract. Again, this is a scale problem when you're dealing with 1.7 million. I have done larger scale translations, and what you can do is you can take very similar code to this and then run it on a node in the cloud. You can really get a super powerful, run it in parallel, so you're not just trying to do all these sequentially. But anyway, this is the link to that video we just watched. There's a link to that video. You can get it by going here. If we go here, and then you go into that video, and then you go to all the files, and then you grab the, you can link toward the MP4 there. I know it's really small. That's the MP4. Then that's where I got that link. And oh, you can also search the Internet Archives. They have an API, so you don't have to go find each one of them. You can run a search. It'll give you metadata back, and then you can extract URLs from that. I'm not going to demo that today, but that was a big, that's an essential part of it. Yeah, there's an API from Internet Archives to do this. Okay, so, and then the thing about this system is you do have to extract an audio file, a FLAC file, and use Google Cloud Storage to do it. I don't believe that all systems require that you do this. So, but anyway, here we have it. This is all boilerplate. I just want to show you a couple of things. First, this is actually the result that we're going to get from Google Cloud Platform, from the service that did the transcription. And you notice it's going to give us extremely detailed. First, it gives a confidence score now. This is the this is the algorithm's confidence in its own translation. This is not somebody else who came from the outside and audited it. But this helps because there's a mathematical meaning to confidence, the way they're computing it. But it's really useful for is a relative measurement. What if 90% of your collection had like a 99% confidence score, but then only 10% of it, about 10% of it, say, had an 80% confidence score. That's worth looking into. I would want to look at some of the transcriptions for the lower and see how we're doing. Am I losing a lot of data? So it's very useful as a flag to give yourself a sense of, is there a lot of variance? Because if I'm drawing conclusions about what the whole data set means, am I actually letting 90% of my data completely determine that? What's going on with the other 10%? And here you see, we've got like timestamps, words. It's very, very elaborate. And then, but if you just want the, see, this is what you would probably get if you're only looking at the transcription. Now, we just watched the video and it's pretty good. I actually think this one's pretty good. They said in the end, we're not in this business for our health, not for help. So it's not 100%. What I like to do is, since it comes block by block, one approach I've taken is to give the confidence score for each block. If you want to go up one level in abstraction, you could give maybe a median or mean confidence score and give it depends on how many. Maybe you have to give the min, the max, the interquartile range. You can give some very descriptive statistics because it might be that almost all the video was great and it was just one little section of it wasn't so bad. Here's the thing, they merge topics into the videos, right? Like it could be a news program where they're discussing something that happened and then they show the clip of what happened and they go back and you see, you don't want to lose that. So you might want to be more granular about it. It's very, see, I'm not going to be able to give a lot of very specific advice because I think it's going to be collection specific. So let's look at the next one now. This is for a PDF. And this is for that PDF image we were looking at. And this is the, I think this is it. Did I run this? Oh, this is a different one, but this is one that translates a little better. So let me go back and see if I can find, going to see if I can find the URL for some handwriting. I think there's a handwriting one here. Let's see, let's look at this and see if we get some handwriting. So I will go back to the tobacco documents. I'm going to search on it. Okay. And what was it? Okay, so this is a PDF file. And this is, so what we can do is, this is a handwritten document. So you feel free to look at, please do look at it more later. Right now, I want to look into how the translation's working. So what I'll do is I'll grab the ID. Again, you can get this from the API. You don't have to go through this process. I wanted to do it for today. And I'm just going to rerun the whole kernel on this. And what it's going to do is it's going to, see, this system requires that the PDF file be on Google Cloud Storage. If it were just an image, I could just point to where it is on the web. But PDFs involve a slightly more involved process. And I'm not sure it's going to stay that way. Like it's getting better. Okay, and so again, here's the response. And you see that we have a lot of information. What language is it in? What's our confidence in the language? What are the, where is the text located? Sometimes, you could care. So I just want, this is all information that would be available to a researcher or for you to give to a researcher. Like this is confidence in, we're looking at like character by character level confidence scores. And this is the number of responses. It was a 4-page document. And this is the translation of that particular document that was part of a letter writing campaign. Now, what I'm doing here is just to show you that, and just you can get, again, it's by, remember it was by block, by sort of time block with the video. Here it's going to be by page block. And I wanted to show you one other thing that's interesting about this is you can get a sentiment score and a magnitude. So it looks like this is an unhappy sentiment score is -1 to 1. Magnitude is again relative, and is related to, it is influenced by the size of the document. Let me quickly show you, just go back to because I only did it here. You can also get categories. This was the video, it was on smoking tobacco products, sensitive subjects, probably because they're talking about people dying. I do want you to know if I used this to try to extract everything that was about smoking, some of the not well translated things aren't going to make it into the data set I give a researcher. So again, you see, there's just so many ways that this can end up really influencing things. We're at 5 minutes and I have shown all the code. So yeah, I've promised a discussion. But I would like to go to the end though, because there's 2 things I just really want to make sure I mention to you. The first is, are you interested in trying this yourself? You're all UC people. So UC Carpentries is happening in mid-September. I'll give you a link in the next slide. So if you want to get up to speed with Python programming, go to UC Carpentries and we'll get you up to speed with the ideas. By the end of all this, you could be writing and running notebooks like the ones I've demoed. So that's thing. And if you'd like to learn more about Python for digital humanities, we just did a sequence at UCSF. We've posted the videos. We're going to run it again, but I want to wait until after UC Carpentries so I have a larger group of people who are ready to start doing some of the more elaborate programming. We've been talking about this a ton because a lot of people at UCs have more specialized workshops that they're only offering on their campuses. Very few people are attending, almost not enough to justify it, but we think if we could, roll them out after this. So here's the links. They're in the slides, so you can download the slides and get those links. There's the Carpentries workshops, digital humanities sequence. UC Love Data Week happened this year in February. It's going to happen again, and we may be able to walk through this much more technically than through a presentation. And if you're interested in working in this kind of data, I don't know if it's frowned on for one UC to do this to other UCs for people who are already employed at UCs, but if you'd like to work with this kind of data, we are hiring a digital archivist. So, you'd work with this. Really, this is it. This is the kind of thing you'd be working with. So, all right. Thank you. That's all. That's all I got. Do we have any time for questions? 3 minutes.
Hear me right. So I pulled up a bunch of print ads while we were browsing through the thing. So it's a combination of text and images. When you run something like that through the topic analysis, does it know that the images are there? Does that count in any way towards its confidence, or does it strictly like looking at the text and transcription of the text when it calculates like its confidence score about the document?
Okay, good question. Because I think I know what you're asking, and I can tell you the answer I'd give you if I needed to give you an answer, whether it's an image is in the metadata that we have at the library, but you're kind of interested in whether would this tell you that it's an image. I haven't used it to, but I wouldn't be surprised if it does. I just not sure. But yeah, I wouldn't be surprised if this or some other technology that's like it would know that it's a video or an image. Yeah, probably would be able to at least give you like a probability. I'll check the online comments. Don't see any questions, but you're free to email me questions, and I would love to see you at some of the workshops. So I think we can wrap it up here. Thank you so much for coming. Thanks everyone online.